Lewis structures can be used to demonstrate ionic and covalent bonding between elements. Both the Lewis dot structures and the bonding depend on a knowledge of the valence electrons for the groups of elements in the periodic table, as well as the oxidation numbers, or ion charges, that form when electrons are transferred. As a recap, group 1 have one valence electron. When that valence electron changes, then that element becomes an ion with a charge of +1. Group 2, the alkaline earth metals, have two valence electrons. If those move, they take on a charge of +2. It continues in the p block with group 13, or 3a, having 3 valence electrons, then 4, 5, 6. The halogens have 7 valence electrons, and finally the noble gases, which don't react and don't form bonds, have 8 valence electrons, the octet. Everybody's goal is to bond so that they have 8 valence electrons. For the nonmetals, the oxidation numbers are shown below in blue. Group 13, if they lose their 3 valence electrons, have a charge of +3. Group 15 have 5 valence electrons. Only 3 more are needed, making it a -3 charge if they gain 3 extra electrons. Group 16 take on a charge of -2, and of course the halogens, being 1 electron away from the perfect octet, take on a charge of -1 when they gain that 1 extra electron. Ionic bonds are the result of the transfer of electrons from one element to another. The group 1 metal, potassium, has 1 valence electron. The halogen, fluorine, has 7 valence electrons. The 1 valent electron from potassium can transfer to fluorine in order to give fluorine the complete octet. The additional electron gives fluorine a charge of -1, leaving potassium minus its 1 valence electron with a charge of +1. This is an example of an ionic compound. Let's use sodium and chlorine as an example of ionic bonding. First, we need their valence electrons. Sodium has 1 valent electron. Chlorine has 7 valence electrons. When sodium's electron transfers to chlorine, then chlorine takes on a charge of -1, leaving sodium with a charge of +1. And this is the formation of table salt, sodium chloride. Another example is the ionic compound formed between the bond of lithium and sulfur. Lithium has 1 valent electron, while sulfur has 6. While lithium can transfer its 1 valent electron to sulfur, there's still one more vacancy. A second lithium atom will be required to complete the octet for sulfur. Therefore, the formula for the compound with lithium and sulfur involves 2 lithium to every 1 sulfur. The molecular formula is Li2S. When atoms bond to form a covalent bond, they share their valence electrons until everybody has a complete set. The molecule formed between 1 carbon and 4 iodines is a good example of covalent bonding. Carbon has 4 valence electrons. Each iodine has 7 valence electrons. By sharing, they provide carbon with an octet of 8 electrons, and each iodine has 8 electrons as well. Sometimes, due to unpaired electrons, these molecules form a shape known as bent because of the unpaired electrons that repel one another. For example, water. Oxygen has 6 valence electrons. Hydrogen each have 1 valent electron. So the bonds between oxygen and hydrogen only involve 2 of oxygen's valence electrons. That leaves 4 of oxygen's valent electrons free to be unpaired electrons. The repulsion from these electrons causes the water molecule to be bent and also polar, with a partial negative end as well as a partial positive end.